Hello everyone. Today I am going to explain the solutions of AtCoder beginner contest 239. I will explain the solutions for problem A to E. So let's start with problem A. The problem A was very easy. Here we were given a value x and we had to simply calculate square root of x into 128,000,000 plus x. Here is nothing to understand or explain. So I simply took the input in x, then I calculated x into 128,000,000 plus x, and then I took the square root of this and I printed the answer up to 9 decimal points. That was all about problem A. Now let's see problem B. Now in problem B we will be given an integer x which can range between minus 10 to the power 18 to 10 to the power 18, and we have to print the floor value of x by 10. Basically here it's the floor sign, but it's not asking us the floor value. Here this sign denotes the maximum integer not exceeding x. So what it says is that for a given number, let's say we are given 2.4, so we have to return that integer which is maximum but not exceeding 2.4. so if I draw a number line like this, so let's say this is 0, 1, 2, 3, 4, 5, and here minus 1, minus 2, minus 3. Now 2.4 lies somewhere here. Let's say this is 2.4. So we have to return the maximum integer which is not exceeding 2.4. So that value will be this 2, because this is the value which is not exceeding 2.4. So for 2.4 our answer will be 2. Same way for 4.5 our answer will be 4. But when we are given a negative number, let's say minus 2.8, so minus 2.8 will be, let's say, somewhere here. This is minus 2.8. so in this case if we just simply do the division minus 2.8 by 10, then our answer will be minus 2, right? But this is not the correct answer. Why so? Because we have to give the maximum maximum integer value which does not exceed the given number x. So for 2.8, if we give this answer, this is exceeding x, this is our x, and we cannot give minus 2. Instead our answer will be minus 3, because this is the maximum value, because in this side the more we go left our value becomes lesser. So this is the highest value which is not exceeding x. So for minus 2.8 the answer is minus 3. So if we check for 2 or 3 examples of negative numbers, we will see that for negative numbers the answer is nothing but the ceiling division of that number by 10. So for minus 2.8 the ceiling division of this number by 10 will be minus 3. So that is all we have to do in this problem. So I can show you in the code that first I take the input and I check if x is less than 0, then I simply give the ceiling division value, otherwise I just do the floor division of x by 10 and I print that value. So that was problem B, and now let's see problem C. Now in problem C we are given an xy coordinate plane and we have to check is there a lattice point whose distance from two lattice point x1 and x1 y1 and x2 y2 are both root 5 or not. So basically the problem asks us that if we are given 2 points on the coordinates xy coordinate x1 y1 and x2 y2, we have to tell whether there exists a lattice point whose distance from this point to this point will also be root 5, and from this point to this point will also be root 5. Let's say this point is xy. Now how can we find the distance between 2 points? The formula is given here. This is nothing but a minus c whole square plus b minus d whole square and whole root of this thing, right? Now for this value has to be root 5, so we can we can ignore the root value. So this value a minus c whole square plus b minus d whole square has to be 5, right? So that means there are two options, whether this value can be 4 and this value can be 1, otherwise this value can be 3 and this value can be 2. Actually they can be interchanged, like this can be 1 and this can be 4, also this can be 2 and this can be 3, right? Now we have to check whether that exists or not, but before that we need to check another thing, that in order to be a minus c whole square equal to 3, then a minus c must be root 3. Now any two positive integers distance, I mean for two positive integer x and y, their distance can never be a root value, right? So this may and for lattice, and we are given that we have to find a lattice point. And what is a lattice point? Here it says that yeah, here it is given that a point on an xy coordinate plane whose x and y coordinates are both integers is called a lattice point. So our x and y both must be integer, but if x, I mean if a minus c, or let's say if x minus, our point is xy and one of the given point is x1 y1, so now in order to x1 minus x whole square to be 3, x1 minus x equal to, this will be root 3, right? Now this, if this value is root 3, then neither x1 nor x is a positive integer, right? Because for two positive integers the distance between them can never be a root value. So this way this option of 3 and 2 is out, so the only option left is 4 and 1. So what we have to check, that for, let's say we are given 2 points x1 and y1 and x2 and y2, we will consider all the possible points which are 1 and 2 distance away from x1 and y1. So what I am trying to say is that, let's say we are given a point this x1 y1 and we are given another point x2 and y2. First, see, our target is to get the distance equals to root 5. That means x1 minus x plus y1 minus y whole square is has to be 5. So if there are two options, either this is 1 and this is 4, or this is 4 and this is 1, which means x1 minus x, this value has to be either 1 or, I mean, or 2, right? Because when it is 2, then its square will give us 4. Same way, when this is 1, this has to be 2, or and this, when this value is 2, this value has to be 1. So this way I try to discover all the possible combinations of points which are which are plus which are delta plus minus 1, delta plus minus 2 away, or delta plus minus 2 comma delta plus minus 1 distance away from x1 y1. And let's say our given coordinate is for x1 y1 is 4 and 5. So the possible points for which we will check are, either for when I do plus 1, there are two options, 5 and 5, and I am doing plus 1 in these cases, right? So this value has to be either plus 2 or minus 2. So if I do plus 2, then this will be 7, and if I do minus 2, then this value will be minus 3. And another possible combination will be when I do minus 1 in this position. So in case of minus 1 and minus 1, this value will be 3 and 3, this value minus 1, and this value again can be plus 2 or minus 2. So if I do plus 2, then it will be 7, and if I do minus 2, then it will be 3. Same way, there is another combination when I do plus 2 with x1, I mean x coordinate, then this value will be 6, and there are two combinations for that, plus 1 and minus 1, because I have taken plus 2 for the x coordinate, so y coordinate has to be either plus 1 or minus 1. So the values are either 6 or 4, and the last combinations are for minus 2, I mean for taking minus 2 on the x coordinate. Then there will be two more options, minus 2 and here plus, I mean plus 1, let's say. So this will be 6 and this will be 4. So these are the options, I mean these are the all possible combinations, but I mean these are the points from where we can try to find the solution, because all these points, like this point, all these points are root 5 distance away from this point. So let's say this is the point, I mean these are the points which belong somewhere here, like these areas, and all these points are exactly root 5 unit away from x1 y1. Now we have to check whether the distance between this point and x2 y2 is also root 5 or not. If it is also root 5, then we can find a lattice point which is exactly root 5 distance away from both the given points, and if there is no combination like this, then our answer will be no. So let's see the code. Although my code for this problem is not clean because I tried to hard code it, but it can be done better. So first I created a function for finding the distance between 2 points, which is nothing but a minus c whole square plus b minus d whole square. Also the distance is root over of a minus c whole square plus b minus d whole square, but what I did, I neglected the root value, so I am always getting the distance square value, right? So if the distance is 5, this function will return me 25, or when it is root 5 the distance, it will return me 5. Then just like I showed here that there are these many combinations, I explored all the combinations, like when I am doing x1 plus 1, and for y1 I am doing plus 2, plus 1 minus 2, minus 1 plus 2. These are the combinations, and for every combination I check the distance, because I know that this combination like p1 and p2 is like point p1 p2 is exactly root 5 distance away from x1 y1. Now I am checking the distance between the point p1 p2 and x2 y2. If this also gives me 5, it gives me 5, which means the distance is root 5. So yeah, this point is the lattice point which is exactly root 5 distance away from both x1 y1 and x2 y2. So I return, so I print yes and I return from the function. And after checking all the possible combinations, if I did not find any combination like that, then I simply print no. Okay, so that was problem C, and now let's see problem D. So in problem D, there are two players, Takahashi and Aoki. First, Takahashi starts the game and he will be given an integer, I mean he will be given a range a and b, and he can choose any number between that range inclusive a and b. And then Aoki is also given a range of c and d, and he can also choose any integer between the range c and d inclusive of c and d. Now if these two numbers, like Takahashi picks a number and Aoki picks another number, and if the sum of these two integers is a prime number, then Aoki wins, otherwise Takahashi wins. Now both the players play optimally, so we have to tell which player will win, right? So the first thing notice here, this the game is started by Takahashi. So what will Takahashi do? Like both players play optimally, so Takahashi will always try to choose an integer between a and b, so that if Aoki chooses any integer between c and d, the sum of those two integers will never be a prime number, right? So Takahashi will always try to choose an integer so that adding any number between c and d with the chosen integer by Takahashi, the sum of those two integers will never be prime. Okay, so if Takahashi can find any number like that between a and b, so that for that number there is no possible way to add another number between c and d, so that the sum is not a prime number, then Takahashi will win, otherwise Aoki always wins. So what I am trying to say, let's say for the given example 2 3 and 3 4. So A is 2, B is 3, C and D 3 and 4, right? Now Takahashi can choose any integer between 2 and 3. So there are actually for Takahashi two options, either 2 or 3. Now if Takahashi picks 2, see, there are the what are the prime numbers, like 2, 3, 5, 7, 9, right? Now if Takahashi chooses 2, then Aoki will choose 3, because 2 plus 3 will be 5, which is a prime number. So Aoki will win this time. Also, if Takahashi chooses 3, then Aoki will choose 4, right? Because he has the option to choose any integer between 3 and 4, so he will choose 4. Thus the sum will be 7, which is also a prime number. So again Aoki wins. So in both the cases Aoki will win. So only that time, like let's say there is a range of A and B and another range C and D. So if there is a point I such that for I plus any number between C to D, I plus C, C plus 1, C plus 2, dot 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 up to D, for any number in this range, if we do the sum of I plus any of these number between C and D, if this is not prime, then Takashi will always choose this number I, because if he chooses this number, Aoki can never make up prime number from this, right? So in that case Takashi will win. And if there is no I, no such I here, for which and if there is no such I in this range A of A and B, for which Aoki won't be able to find any J for which I plus J won't be prime, then Aoki wins. So once I show you the code, it will be more easier to understand. So see, first I stored all the prime numbers up to 200 in this vector of integer primes, because here in the question we are given that A and B and C and D both can range up to maximum of 100. So the maximum prime possible, the maximum possible prime for Aoki to get is up to 200, because 100 plus 100. So first I store all the prime numbers in primes, then I initially keep prime found equal to true. So initially I assume that Aoki will always find a prime, right? Also, yeah, this line is not required. I don't know why I wrote this line. So then I just brute force for I between A to B in the range. First I assume that I have not found any combination for which there is a prime, so I initially keep it true. What I'm trying to say is that for each I between A and B, I run a loop, a J for C and D, and I check if adding J with I gives me a prime number or not. So I and J will be a number, and I try to check in my primes array whether that number exists or not. If that number does not exist, that means I plus J is not equal to prime, and if that exists, which means IT is not equal to prime cent, that means adding J with that I will give me a prime number, which is in favor of Aoki. So in that case I write not found equal to false. Now after checking all the J, after checking all the values between the range C and D, if I never found a J for which I plus J, if I never found a J for which I plus J is a prime number, that means if Takahashi chooses this I, Aoki can never make a prime number from this. So in that case I simply print Takahashi, because Takahashi will win by choosing this I, and I return from the function. Otherwise at the end I print Aoki, because Takahashi did not find any I in the range A and B for which there does not exist any J, so that I plus J is non-prime. Not any J, there does not exist a single J for which I plus j is not prime. So that was problem D. This problem was also very easy, and the last problem I will explain is problem E. Now I could not solve it under the given time of the contest. I solved it after that. Also I got a TLE on the submission, and then I had to optimize it a bit more. But yeah, let's see the problem. In this problem we are given a rooted tree with n vertices, and the vertices are numbered from 1 to n, and always the root of the tree is 1, I mean vertex 1. Then we are given edges like ai to bi, and for on every vertex there is a value x written on it, and then we will be given q queries. For the ith query we will be given a pair of integers vi and ki, and the question is, among the integers written on the vertices in the subtree rooted at vertex vi, find the kith largest value. So let's see what the problem is actually asking us to do. Let's say this is the input. I will first draw the tree for this one. So there are 5 vertices, and initially they have started from vertex 1, but I will start from vertex 0. Okay, but here for explaining I will use vertex 1, but in the code I will start from vertex 0. So here the 5 vertices, the value on the vertices 1 2 3 4 5, which means nothing but on the first 1th vertex 1 is written, on the second vertex 2 is written, on the third vertex 3, and so on. Now the edges are like this, like there will be n-1 edges because it's a tree obviously. So the first edge is 1 and 4. Initially 1 is the root of our tree, then there is a edge of 1 and 4. Then there comes the edge 2 1, so we will connect 2 with 1. Then the next edge is 2 5, so we will connect 5 with 2, and the next edge is 3 2, so we will connect 3 and 2, and that's all. This is the tree. This is the tree we are given. Now there are 2 queries. The first query v is 1 and k is 2, and the next query 2 and 1. So in the first query it asks to print the second maximum value in the subtree of vertex 1. So this is the vertex 1, right, and it asks us to give the second maximum value in this subtree. So for the subtree from vertex 1 is nothing but the whole tree, and we have to give the second maximum value, which is see, in vertex 1 the value, this is the vertex number, right, 1 4 2 3 5, and the value which are written on these are also 1 4 2 3 and 5. These values can differ. It is not necessary that on vertex 1 there will be always 1, but for this test case the values and the vertex numbers are same. Now in this subtree, what is the second maximum value? The second maximum value is 4. So for this one the answer will be 4, and the next query is for vertex for subtree with the vertex 2. So this is vertex 2, and the subtree formed by this vertex is this 2 3 and 5, and between this in this subtree the first largest value, which is nothing but the largest value in this subtree, is 5. So for this one the answer will be 5. So yeah, the output is given 4 and 5. Now the first thing to notice is that there can be 10 to the power 5 queries. So we have to answer each query in order of one time. That was the first observation. Now how can we do that? So for that we have to pre-compute something, right? Also one thing to notice, which I missed initially, for which I had TLE, that k can be at most 20. Okay, so this means that for each subtree at most we can be asked to give the 20th largest value in that subtree. So now how can we do it? So if we think of this problem recursively, like let's say this is tree, okay, this is a tree, like it will also have some subtrees from here. Now see, let's say that the value of k at most can be 20, right? So for this vertex, if I know the 20 largest values in this subtree, largest values in this subtree, same for this one, the 20 largest value. Otherwise, if it does not have 20 vertices in this subtree, then that much, like 10, okay. So whatever it is, what I'm trying to say, that if we know the largest value in these subtrees, all largest values, also we know the all largest values in this subtree for this one also and for this one also, okay. Now if we combine all the values of these subtrees, also we add this value x, and after that if we sort this whole value, then we can find the largest values, right? So what I'm trying to say, let's say this subtree has values like 1, 2, 4, okay. This subtree has values 7 to 10. This subtree has 81, 90, and this subtree has nothing. Let's say this is the leaf node for this one, and this value is 74. Now when we are at this vertex, so let's say we for 74th value, let's say this is the first vertex, okay, and there was written 74 in that vertex. So if we are asked to given the second largest value in vertex 1, also the fifth largest value in vertex 1, then we have to answer all this query in order of one time. So beforehand we need to calculate the values of all the largest values, right? What I'm trying to say, see, these values at most can be 20. So for each vertex, if we know the 20 largest values in this vertex subtree, then we can simply answer it. And how can we note these answers? So for each vertex, if we know, let's say we are at currently this vertex, and this has these two childs. So if we know the answer for this subtree, like this subtree, and also the answer for this subtree, the k largest value for this subtree and k largest value for this subtree, then if we combine these two array of largest values, then there will be a larger new array. And also when we have to calculate the values for this vertex, this subtree, then also this value will also be added. So if we also add this value here in the new array, and after sorting, the first k values will be our k largest values for this subtree, right? So this is nothing but a recursive approach using DFS. So that was all about this problem. I can show you the code here. So initially I take the input, the number of nodes and vertices, and how many queries will be there. Then the values, like these values, like for ith vertex, what will be the value written on it, I have taken that in array x. Then I form the edges, like if we are given a and b, so I have formed the edges, like I have created a 2D vector, and for each a, b, I have first did a minus minus, b minus minus, because I have started counting vertices from 0, 1, 2, 3 this way, because they were given 1, 2, 3, 4, 5. It can be done this way also, but I prefer to do it starting from 0 vertex. So I decreased the value by 1 and I formed the edges. Then I have created a vector of vector answer, which will store the pre-computation values for each vertex. So what will this answer array will do? So the answer of I stores all the largest values in the subtree of vertex I. Okay, so if we are asked to answer for ith vertex the kth largest element, then we can simply access that value from answer I of k, or rather I will say that it is I minus 1 and k minus 1, because I have decreased the vectors by the vertices by 1 because I have started from 0, and k minus 1 because when we will be asked to give the first largest value which will be stored in the 0th vertex, so I am doing k minus 1. You can check the code and you will get that part. So initially I do the DFS from my root, which is 0th vertex. So first I call the DFS on its childrens, because what I need, for a vertex for this vertex, if we want to store the answer for this vertex, first we need to know the answer for these vertices, right, its children vertices, because if we know the answer for all of its children vertices, then we can simply answer for this vertex also using these values. So first I call the vertices on its childrens so that they can do their works and store their values. Right, now I am again at this vertex. So first I have called the DFS. Now I have created a vector v, because in this vector v I will store all of these subtree's largest values, this subtree's largest values, and this subtree's largest values. Okay, so that is what I am doing here. But initially I have told you that when I am calculating for this part, I mean the subtree for this vertex, then this value will also be included. So I have included this value too here. In v, first I have pushed the x of current, because currently I am current node and the value written on current node is stored in my x array, so I have put it in vector v. Then for every children of this current vertex, so for every children, I mean for this children, this children, this children, I go to them, and in each of them the largest values, because first I have calculated the answer for these values recursively. So now in my vector v I am storing the answers from my child. Like if this vertex had the largest values 2, 3 and 4, and like they will be in increasing order 4, 3, 2, and this one had 5, 9, 11, and this one had 1, 2. So what I am trying to do, I am creating a vector. Let's say this is the value 10. Then in my vector I am first pushing my value 10, then I am going each of its children. So first I come to this children, and this children is storing answers 4, 3 and 2. So I put 4, 3, 2. Then I come to these children, I put the value 5, 9, 1, 11. Then I come to these children and put these values 1, 2. Now if I sort this vector, then this will be 1, 2, 2, 3, 4, 5, 9, 10 and 11, right? So now I mean if I will, let's say I sort this in increasing order, then in this will be 11, 10, 9, 5, 4, 3, 2, 2, 1, right? So now I have the all the largest values for this vertex's subtree. For this vertex's subtree I have all the answers. So that is what I am trying to do. I go to all the childrens and I take their maximum values and put that in my vector v, and after that I sort it in decreasing order so that the first value is the largest value in my vector v. And this is the part where I got TLE. Initially what I tried to do, after sorting this vector v in my answers current, I put this vector v, but I cannot do that because in that case I will get TLE. because in that case what will happen, that for 10 to the power 5 vertices, for 10 to the power 5 vertices, this value will be very large. The size of this vector v will be very large, so we cannot store this many large vertices, because this is a 2D vector answer, but we are given in the question that the maximum value of k can be up to 21. So if we store only the 20 largest value for each vertex, that will be enough for our answers, right? So what I do, I go for the first 20 vertices, first 20 values, and I store them in my answer of current, because I showed that my answer of I stores all the largest values in the subtree of vertex I. So after that part is done, now my answer is properly filled, and then I go for each query v and k, and I directly answer for that query in order of one time. The answer is stored in v minus 1 and k minus 1. This is the kth largest value for subtree of vertex v. So that was all for this problem, and yeah, I have explained up to problem E, because I have also solved up to problem E. So that was all for this problem, for this contest, and thanks for watching.